Let's talk about the power rule for derivatives. This is going to be a formula you're going to use literally hundreds of times in your calculus courses. Here it is. If you have a function that is a power function, what is a power function? Well, it's x to some power, let's say n. Then what is the derivative? The derivative is, well, you bring the exponent n to the front, and then the power of x is going to be one smaller than it was. So it's going to be the power of n minus 1 now, okay? So this is such a useful formula. You're going to use it so much it's going to become second nature to you. And why don't I just write it another way as well? Same thing. The derivative of x to the power of n is n x to the n minus 1. Okay? Just a different way of writing it. I like both ways. So these are the same thing here, okay? So why don't we practice that a little bit? Let's say that, do some examples here. Why don't we take a look at some function like f of x equals x cubed? What's the derivative of that? Well, the power of x is 3, so n is 3. So according to this formula here, the derivative is going to be 3x to the 3 minus 1. So 3 times x to the 3 minus 1. And of course, 3 minus 1 is 2. So we got 3x squared. I usually don't bother with this step right here. I just go directly to that answer, which is no big deal. You can do 3 minus 1 in your head, no problem. How about something like this? What is the derivative of x to the power of 5? Well, it's the same thing. It's just written in a different way. It's going to be 5. You bring that to the front as a coefficient. And then x, and then you're going to decrease the power of 5 by 1 and make it a 4. And that's as easy as that. Now, you should realize that this formula here, n, can actually be any number, okay? In the examples here, I use 3 and 4, like positive integers, but in this formula, n can be any real number. So it could be positive, negative, fractions, decimals, whatever you like. So let's see how that goes when n is, say, I don't know, f of x equals x to the power of negative 6. What would be the derivative then? Well, n is negative 6. What do? We take that exponent, negative 6, bring it to the front as a coefficient, and then we have negative 6 minus 1. So all we got to do to finish that now is just figure out what negative 6 minus 1 is. And of course, that's negative 7. And if you wanted to simplify, you could bring this negative exponent to the denominator and write it like that. And often you should do that because some people don't consider this simplified and they prefer this answer instead. Just read the question and see what they want. How about something like x to the power of 3 quarters? Here n is a fraction, but we can still use the formula. What do? We bring the exponent 3 quarters to the front. Then x is going to be to the power of 3 quarters minus 1. Now, it'd be nice. I hope you know your fractions well. What is, just on the side here, why don't we calculate 3 quarters minus 1? You should know it in your head, but if not, this is how you do it. Let's write 1 as a fraction, okay? We would like a common denominator of 4, so why don't we write 1 as 4 over 4? And since the common denominator is common now, we can easily do the subtraction. 3 minus 4 is negative 1, right? So we get 3 quarters x to the minus 1 quarter. And if you want to simplify this, you can bring that to the bottom. And you get that. And you could even write this as a root if you felt like it. So this would be the fourth root of x. Both of these answers are good. I prefer the fractional exponent. The square root is kind of ugly, or the fourth root is kind of ugly, but it doesn't matter. All right, so we've done some examples there of that power rule. I want to look at a special case of this power rule which comes up sometimes. And it has to do with the derivative of x. Let's say I want to do the derivative of x. That actually falls into this rule because, you know, x is the same as x to the power of 1, right? And so we could use our power rule with n being 1. Let's see what happens. We get 1 x to the 1 minus 1, which is 1x to the 0. And remember, anything to the power of 0 is 1. So this is like 1 times 1, which is 1. So the derivative of x is 1. I find going through all this here is kind of annoying. You don't want to do that every single time. So what I would suggest is just memorize that the derivative of x is 1, okay? Whenever you come to the finding a derivative of x, just don't bother using this power rule. You could, but it's kind of a waste of time. Just remember the derivative of x is 1, okay? So maybe in addition to this power rule here, I can just add on a little fact here. Excuse me. And the derivative of x is 1. Okay? And if you want to write it in this form, I'm just saying that if f of x is equal to x, then f prime of x is equal to 1. Just another little way to write it, okay? So this is what we call the power rule. I hope that makes sense. That's a little bit messy there, excuse me. All right. That's really all I had to say on this power rule. Let's move on to another rule for finding derivatives.